Okay, so in these acid-base neutralization reactions, our last lesson just talked about the fact that in these reactions we have 1 mole of H plus reacts with 1 mole of OH minus to produce 1 mole of water. And this will always be the case in these acid-base neutralization reactions. So if we want to predict what volume of an acidic solution is required to neutralize a given amount of a basic solution, or a base, we can use our mole-mole relationships of our balanced chemical equation. So in this case, we're reacting in acid, hydrochloric acid, so we have HCl, that is aqueous, and then we have calcium hydroxide dissolved in water, so that also is aqueous, and this goes to form, again, liquid water and a salt, which in this case will be calcium chloride, which will also be aqueous, right? And again, to balance these, we simply want to match the H plus and the OH minus, so 2 moles of HCl reacts with 1 mole of calcium hydroxide to give us 2 moles of water. So in calculating the amount of HCl that we need, we're basically going to need to calculate the number of moles. Now in this case, we're given a solution with a known molarity of hydrochloric acid and a given mass of calcium hydroxide. So here we have 5.5 grams of calcium hydroxide. So we're going to, of course, want to convert that to moles. So we need to determine the molar mass of calcium hydroxide. That's 40.08 plus 2 oxygens is 32, plus 2 hydrogens 2.016, so telling us that the molar mass of this guy is 74.10 grams per mole. Now we don't need the molar mass for HCl because we're already given a molarity. So what we're going to do in this case is we're going to go from grams of calcium hydroxide to moles of calcium hydroxide, then convert moles of calcium hydroxide and use our mole-mole ratios to calculate the moles of hydrochloric acid that we need to use. And then since we know the moles of that, we will know what volume based on our molarity in moles per liter. So we're going to take 5.50 grams of calcium hydroxide times 1 mole per 74.10 grams of calcium hydroxide. Okay, so that will give us, as our units cancel, that will give us moles of calcium hydroxide. And now we want to convert that to moles of hydrochloric acid. So we need 2 moles of HCl for every 1 mole of calcium hydroxide. Okay, plugging that into our calculator. 5.5 divided by 74.1 times 2 tells us we need 0.148. I'm going to go to 4 sig figs here. 5 moles of HCl. Okay, and now we're given the molarity here. 0.5 molar, that's 0.5 moles of HCl per liter. So the volume that will equal this, so we have 0.1485 moles of HCl times 1 liter per 0.5 moles of HCl. So we're going to divide by the molarity here, right? So 0.50 molar is moles per liter. Okay, so this will give it to us in liters. I want it in milliliters. I know the problem didn't ask for that, but we know that there are 1,000 milliliters per liter. So that's going to tell us when we divide our number of moles by 0.5 and we multiply by 1,000, we get 296.9. I think I will call that 297 milliliters of my hydrochloric acid solution. Okay, and that's the basic strategy for solving these problems. Figure out the moles of the acid and the moles of the base. In our neutralization reaction, the moles of H plus will always equal the moles of OH minus, at our neutralization point, or what we sometimes call the equivalence point. Okay, so we need to balance our chemical equation, determine the moles of the one that we're neutralizing, in this case the base, and that will tell us the number of moles of our acid based on our balanced chemical equation, and we can calculate the volume if that's what's being asked, or perhaps we could calculate the mass of a given acid that we need to add.